Hello and welcome back. In this next mini video, we are going to be covering a phenomenon called crossing over. And as we have learned in the Meiosis Express video, right, crossing over is a phenomenon which occurs during prophase 1. Of meiosis. And as we discussed in that short video, we learned that it is a way in which chromosomes that we inherit, all right, can exchange genetic information by literally swapping arms of chromosomes. So here in this illustration, I have illustrated two pairs of homologous duplicated chromosomes. All right, so this duplicated chromosome right here we can say is the one which we inherited from mom, and this one on the right we can say is the one which we inherited from dad. Okay, so they have this typical X shape indicating that they have been duplicated. They have undergone DNA replication, and on this sister chromatid on the left we can label this with some gene loci, so with some locations, physical locations of genes, and let's label this A, B, and C. All right. So because this sister chromatid is identical to this sister chromatid on the left, we can also label this side capital A, capital B, and capital C. All right. So the chromosome which we inherit from dad, all right, is the homologous chromosome to this chromosome which we inherited from mom. So it possesses the same genes in the same order, but they may be of different variations called different alleles. So we can indicate that they are different variations of these genes by indicating these with a lowercase version of this letter. So gene locus for A, lowercase b, lowercase c. All right. And the sister chromatid on the right, because this is genetically identical to the sister chromatid on the left, it contains the exact same DNA sequence, lowercase a, lowercase b, and lowercase c. Okay. Now, during prophase 1, something very interesting happens when these two homologous chromosomes come to very close proximity with each other. All right. Now, this little X mark which I've shown here is meant to indicate that these chromosomes become physically connected and we can swap out, we can cross over, we can exchange the arm of this chromosome here with this arm of this chromosome here. All right. So an analogous situation to compare this to would be as if I were to rip off my right arm and your right arm and then stitch mine onto yours and yours onto mine. All right. We would both possess right arms, but yours would be mine and mine would be yours. Okay. So here we have created an exchange of genetic information where we physically swap out these arms of these chromosomes. And the result of this we can illustrate below. So if only these two arms are involved in the crossover event, what becomes of these chromatids? Well, the chromatid on the left here from mom would still have capital A, capital B, and capital C. All right? The chromatid on the right, which used to be also genetically identical to this chromatid, used to be capital A, capital B, capital C, but now contains the capital A locus, capital B locus, and little c lowercase c locus, because this arm was swapped out. All right, this arm of this chromosome from mom was exchanged with this arm of this chromosome from dad. So this chromatid still possesses lowercase a, still possesses lowercase b, but now contains the part of the chromosome from mom, giving it this new C locus. Okay? Now, what of this chromatid on the right? It's been unaffected, right? No exchanges occurred, so there is still the lowercase a, lowercase b, lowercase c. All right? So, which are the chromatids which have been unaffected by the crossover event? This chromatid here on the far left, and this chromatid here on the far right from dad's duplicated chromosome. But these two chromatids, which will segregate during anaphase 2 of meiosis, they are going to contain new combinations of mom's genes and dad's genes on the same chromosome.